Really, in the order that we have done stuff this week, it can be a little out like this. Dang, we're going to get hit with literal equations right off the bat from yesterday. So with these, again, we're trying to figure out whatever is asked of us. Well, it was nice. X is being asked for us in all of these. So the first one, I'll admit it, the first one's a little bit of a doozy. This is kind of trickier than any of the ones we did yesterday. All right, let's see. We want to solve for x. Now, this is going to be kind of a problem. Yeah, wait, x is in the denominator of the fraction. What the heck? So the very first one, so it's in the denominator of a fraction, which means we're dividing. What's my opposite going to be to start? Yeah, we're actually, I'm going to rewrite this underneath because that 4x is going to drive me crazy. So just rewrite it here for a second. So this is going to look weird, but it's not going to be that weird in a moment here. So both sides by the denominator. Oofda. All right. But it does get my x out of the denominator, which is a good thing. And then over here on the right, oh, excuse me, the left, that was the right, left. I can get this correct. We're going to distribute that g through. So we got negative 3g. Yep, this is weird at its finest. Minus 4xg. So good news, x is out of the denominator. Bad news, there's still a whole lot of stuff going on here. But keep the main idea in mind. That x term is still what we need to get by itself. So, what's my next step to work on getting this alone on this side? How do I tell this to go bye-bye? Absolutely. And is the Hardy writing too big going to get us? Let's find out. I think we're going to make it. Barely, but we're going to make it. Oh boy. All right, we finally have the term with x isolated, but now we got to get the stuff away from x. Nice. Since all this is being multiplied, we're going to divide by the stuff that we don't need. You're like, wait. So like, that's it? It is. Because here, you might be saying, but wait a second. Like, I could cancel those g's, or I could cancel those 4s. So, you know, why are you saying we're done? Because in this case, these two terms are bonded together by that plus. And the only way you get to separate the bond is with the exact same set of terms, which we don't have. We are not going to be bond breakers, not in here. So that's as far as you could go. That is probably the worst question on this entire sheet. So that's a good thing. Let's see here. Let's play with one more. Somebody pick one here. What looks kind of weird? You're like, I don't know, Hardy. My voters for the quiz on Monday are going, nah. Protesting this. I'm not saying anything. No, let's see. Let's play number 4, because number 5 I want to leave you because it's kind of like the first one was. So this one's a little more straightforward. No fractions. What's step number 1 on number 4?
Minus the 4.
Minus the 4. Now again here, little stuff. But once we minus the 4, these are not like terms, so I can't do 6 minus 4 and call this 2dr. And you could put the negative 4 plus 6dr too. That's perfectly fine. And then even I can handle this last step. And I would actually prefer, even though you don't have to go this route, I would prefer that you actually leave that as one big fraction like this. Like, you could, if you wanted to, take each piece with it just being a number. 6 divided by -3 would be -2dr. And -4/3 just kind of would stay as a fraction. I don't like that as much as this. I would just leave it alone. It's less stress on the noggin as well, as far as trying to get those set. So that's all we're doing on solve for the indicated variable. Regular Algebra 1 stuff, just with a whole lot of variables involved. And again, if we get to the end and you're like, can you go back and do whatever number? I'm happy to do so, to kind of help out there as well. So that was what we did yesterday, kind of playing around a little bit. Let's see here, what else do we got to be reminded of? Solve by taking square roots. All right, let's see here. Trying to find some ones that are going to be interesting. That'll be interesting. Let's try 6, I think. See interesting by doing this. I want us to be doing the ones that are going to have the most. Actually, let's do 8. So 8 and 9. All right. Craziest stuff is what I want. So the goal is still the same, get my variable term alone. So I will not take up your time trying to deal with that, because our main goal here is going to be what happens at the end. So before you can do your square root to get rid of your squared, you've got to get rid of whatever's in front. Even if it's a perfect square like this, do not square root yet. We want whatever variable it is, in this case v, to be by itself. Okay. So now, if I said, all right, so square root and squared, that's going to cancel. That's cool. There's 2 things I got to think about with my answer. The first is there's 2 answers. So we got to get the plus minus working. Got to have them both. Unfortunately, if I go to do the square root, again, second x squared, if I do the square root of 56, I get a decimal, and we're not doing decimals. We're doing exact answers. So next job, and I may have to bust out my notes for this. Let's see. Can I find mine conveniently? There they are. Let's bust out the notes, because I got help if I need it in the form. Here we go. Let me move this up a bit so we can fit this on here. Of my perfect squares in my notes. So I need to find some number, of course, that's less than 56 that is going to go in. The bigger the better. So if I'm not sure, what I can do is just start dividing these perfect squares in until I find one. Now maybe you're just a rock star and you can figure this out and you're like, dang, Hardy, there's like nothing going in. There we go. So 4 went in with 14. Again, 4 is a perfect square. It will simplify to 2 without the radical. Whenever we break it down, that's how it works. And once we've broken down our radical, we're done. Now, if it would have been a perfect square, that's even better. It's just the number and I'm done. So it depends a little bit on how that's going to work. So if I kind of look similarly at number 9, and we got examples of all these different types too with the breakdowns and stuff. So if you need a little assistance, there's nothing wrong with that. Now, hints here. So let's say I'm rolling along, like 25 divided by 9. Oh, it's a decimal, crud. Okay, that's still not a bad thing. Because if I leave it that way, with that fraction, I always have the option with a fraction of breaking it into pieces. And so if I take the fraction and I break it into pieces, I'm like, wait a minute. Square root of 25 is 5, and the square root of 9 is 3. So I can get an exact answer still. And that's what we need to do. No decimals with this. The only time we allow decimals is in application problems. So you might have a fraction. It might break down nice. It might break down with a square root. Shoot, it might just be a perfect square. But for any of those, that could absolutely be the case and work. All right, let's see what else I got rolling here. Okay, so the next part, we've got our radicals here. We're kind of seeing a pattern develop here. Even with the squares, we wanted to get the variable term alone. Here, I want to get the radical term alone. Whatever we got to do. Then it turns into a discussion. Because it's very easy with these. Because we're kind of looking back up at number 8 and number 9. We're like, okay, square root and squared are opposites. They cancel each other out. We saw that up there. So here, once my radical's alone, I can square both sides. Because those will cancel. But here's the thing. This time with a radical, there's no squared in the problem. Well, what does that mean? There's no plus or minus when you're dealing with a radical. Only when you're dealing with the squared stuff. So we got to be careful that we don't put a little too much into some of these, because that can get us in trouble. So just keep doing your opposites. That positive 3, if we subtract it out, and now it's just details. Like here, I'm not adding 23, because that's in the middle here. We're just going to divide that out. And you do want to take a moment.
I checked, and there was a problem.
We have a problem?
Yeah, so I did the math, and if I do like 23n times, wait, hold on, it's a negative. Never mind, I typed it in wrong.
That's all right. So here, yeah, let's check here. Let's make sure things are on the up and up. So we got 3 minus 23 times negative 2.
No, always. I just typed in one.
Hey, I do that stuff all the time. Square root of 49 is 7, plus 7 is 14. We ended up okay, but it was smart to kind of have the, not sure about this one. It's a negative.
If I forgot the negative, so I typed in the negative, and guess what? There was a non-real answer. I was like, uh-oh.
So, yeah, we'll want to check, but most of the time your answers are going to work. So we would just kind of be unfortunate if that didn't occur. Other than that, let's see here. What? Oh. Okay, 15's weird. Let's play this. So here's the good news. My radicals are alone on each side. As long as I only have one on each side, I'm okay. Like we still, if there's other stuff going on, we'd want to get it out. But here, that's not a problem. So we can square right away. That'll help some. So it'll just get us down to this. Ooh, okay. So now that the radical's gone, what should I do now? Okay, let's get rid of the fraction. Important to note when you do multiply by 4, the other side, I want to have parentheses here because I want to make sure the 4 goes to both things, not just the 36. So a little distributing action here. Now we're actually in business. I would move the 8v over because this side just has v already. If I move this over, I'm going to have more steps that I got to do. I don't want more steps. I want less steps. Let's see, are we fortunate and this goes in nice? We are. Make sure that works. 16 divided by 4 is 4. 2 times 16 is 32. 36 minus 32 is 4. Yeah, we're good. We made it. We survived. Good job. So a little radical action, and I think we're going to be wrapping. Oh, almost wrapping. Interesting order I decided to put these in. Absolute value equations. 2 answers. 2 equations.
I remember as soon as you said 2 answers, I was like, how do you do this? And you said 2 answers. Oh, wait.
Yeah, it's like we got the stuff with x squared where we got to do 2 answers, and then these we don't even see a squared, and there's got to be 2 answers. What the heck? So here, lucky us, absolute values alone already, so I can immediately go to my 2 equations. And the only difference
Is the sign.
that's right, is the sign on the second one. We got to switch it over to negative. And on these, as long as you've done your math right and you remember the negative here, you will not need to check these. These will work. Our fingers are crossed, we think. See if I have any weird. Okay, I don't think I have any weird. Let's see here. Ooh. Ooh. Okay, I need to hang on a second because I got people still writing and I'm flipping pages and doing all sorts of crazy things. So let's see here. Just as an FYI, the quiz itself is a little bit shorter than this. So it will not be. I just wanted to make sure we could do some together, and I still left you some. I didn't want to go too crazy. Okay. Oh, I definitely see the one I want to do here. 21. Oh, this sucks people in every time I do it. 21. And it's natural. People will look and they'll say, oh, 9 minus 4. 9 minus 4 is 5. Then they'll put the 5 in front, divide it out. Well, here's the problem. That minus 4 is attached to this, okay? This has the absolute value. This does not. So we cannot do this first. We have got to get that 9 out of there. And no worries yet, because remember, we don't want to see a negative on the right side or there'd be no answers that would work. But luckily for us, or maybe not, I don't know, it depends on how you look at it. Negative divided by negative gets me positive. Now I can do my thing. Not until it's completely alone, though. And once we do this, we're back to Algebra 1. So, and yes, we can divide 0 by stuff and get answers.
0 is allowed to. 0 is allowed.
It's true.
Because it's not negative, and that's all we care about.
And even though we might not be a fan of it, fractions are allowed too. So don't think if you get a fraction that's a terrible thing, that you've done something wrong. That's probably not the case at all. But do keep it in a fraction if you could. That does make things more acceptable. All right. Last thing. I should have had this right after the radical part, right after the squared part, but, you know, life happens. So I look here and I'm like, all right, simplify. Oh, we're back here again. All right. So, yes, well, we should take on the nasty one. That's only right. So I'm looking at these, I'm like, simplify. Oh, this is the no. This is where I got to do this stuff. Yep. So let's play the game with 343 here. You're like, Hardy, look at how many, like, those are all possibilities. I mean, yes and no. Most of the time, the huge ones aren't going to go in. We'll try a few. We're going to see how fast Mr. H can type some of these in. I'm real confident that none of those work. 196 is the first place I'm going to start doing. All you mad, crazy texters and doers of all things on your phone, you should be able to go faster than the old guy does. I mean, I'm nowhere near. Now, I have calculator experience. That's... Oh, there we go. So 49, that's a pretty decent sized one. So 49 and 7 is going to get me there. Ooh, 7s are wild. Maybe it's my lucky day. Square root of 49 is 7. That stays under the radical. And we're going to be good with that. The other one I want to do, because I've seen this happen with classes at all levels before, and I want to make sure it doesn't happen to us. We're going to do 25. So start playing with 80 until you find a big old perfect square that's going to go in, and then let me know. I'll have you do that part, and then I'll jump in with the watch out part. And I'll tell you it's going to be bigger than 4 that goes in, even though that does. What perfect square will get into 80? Get my list up here.
16.
16. So the square root of 16 is 4. Notice, as soon as you do it the radical is gone. The reason I say that is sometimes people will look when it breaks down and it's 4, and they're going to be like, hey, 4 is a perfect square. I'm going to break it down again. You can't do that. It has served its time. It is out on perfect behavior. Do not put it back in radical jail. That is not a good thing. Not fair, not right. You break out, you're good. Okay, 5's still acting a little irrational, so 5's got to hang out for a while. But that's okay. We'll get there. So that basically is an overview of what you're going to see tomorrow. So